Take a look at your laptop charger cable. See that small cylinder near the end? It might look like a simple design detail, but it's actually solving a problem most people don't even realize exists. Without it, your electronics could interfere with each other in surprising ways. So what exactly is inside that little bump? And why has it quietly stayed on our cables for decades? Let's find out. That small plastic cylinder is called a ferrite bead. You might also hear it called a ferrite core or a ferrite choke. And even though it looks like part of the cable's outer design, inside it is a ring made from a special magnetic ceramic material known as ferrite, mostly composed of iron oxide combined with other elements like nickel or zinc. Instead of being attached afterward, the cable actually passes directly through this ring. That's why the cylinder looks like a natural thickened section of the wire itself rather than an extra accessory added later. And despite how simple it looks, this tiny component begins working the moment electricity starts flowing through the cable. In fact, once you start noticing ferrite beads, you'll begin seeing them almost everywhere. They appear on monitor cables, printer wires, camera equipment, game consoles, external hard drives, microphone connections, and even some older television cables, which raises an interesting question. If something this small appears on so many different devices, what hidden problem is it solving? The answer lies in something happening around you right now, whether you notice it or not. Every electronic device in your home is constantly surrounded by invisible electrical activity. Whenever electricity travels through a wire, it doesn't just move quietly from one place to another. It also creates tiny electromagnetic signals that spread outward into the surrounding space. In simple environments with only one or two electronic devices, this usually isn't a problem. But modern homes are not simple environments anymore. Today, your laptop is sitting near a Wi-Fi router. Your phone is communicating with cellular towers. Bluetooth signals are connecting headphones and speakers. Televisions are receiving wireless transmissions. Smart devices are constantly exchanging background data. And all of these signals are moving through the same space at the same time. This creates a crowded environment of overlapping electrical activity. And without careful control, those signals begin interfering with one another. This effect is called electromagnetic interference, or EMI. Sometimes EMI is harmless and goes completely unnoticed, but sometimes it creates strange and confusing problems. Speakers may produce faint buzzing sounds. Displays can show flickering lines. Wireless connections might suddenly weaken. Chargers may behave less efficiently. And sensitive electronics can become unstable in ways that are difficult to explain. What makes EMI especially interesting is that the cables themselves can both send and receive this interference. In other words, a charging cable doesn't just carry electricity, it can also behave like a tiny antenna. It can broadcast unwanted signals outward, and it can absorb unwanted signals coming from nearby devices. That's where the ferrite bead quietly begins doing its job. Instead of blocking electricity, it filters electrical noise. Ferrite materials have a special magnetic property that resists rapid changes in current. And high-frequency interference is exactly that, a rapid, unstable change in signal behavior. So when unwanted electrical noise tries to travel along the cable, the ferrite bead weakens it. Some of that noise energy is absorbed. Some of it is converted into tiny amounts of harmless heat, and the rest is prevented from spreading further into the device. Meanwhile, the steady electrical power your laptop actually needs continues flowing normally. This allows the charger to do its job efficiently while reducing interference at the same time. That's why the ferrite bead is usually placed close to the end of the cable near your laptop. That position gives engineers the best chance to stop interference before it reaches the most sensitive components inside the device. It also prevents the cable itself from acting like a broadcasting antenna that spreads electrical noise into nearby electronics. So the ferrite bead is quietly working in two directions at once, blocking interference from entering your device, and reducing interference leaving your device, all without adding complexity for the person using it. What makes this small component even more interesting is that it represents a much older story than most people expect. Ferrite materials first became important during the early 20th century, when engineers were trying to improve radio communication systems. At the time, controlling unwanted signal noise was one of the biggest challenges in electronics. As radio technology improved, ferrite components became essential tools for shaping and stabilizing signals. Later, during the rise of television broadcasting, ferrite cores helped engineers manage interference inside receivers and transmission equipment. By the time personal computers began appearing in homes during the 1980s and 1990s, ferrite filtering had already become a trusted solution for controlling electrical noise. And as homes filled with more electronic devices than ever before, the need for simple interference control solutions increased dramatically. The small cylinder on your charger cable is part of that continuing story. It represents decades of invisible improvements designed to make modern electronics work smoothly together. Interestingly, newer chargers don't always include that visible cylinder anymore, but this doesn't mean the problem disappeared. Instead, engineers found ways to build better shielding directly into cables and move filtering components inside charger adapters themselves. So even when you can't see the ferrite bead anymore, its job is still being done somewhere inside the system. And ferrite filtering is still essential today in environments where signal stability matters even more. Medical monitoring equipment depends on it. Broadcast studios rely on it. Aircraft electronics use it. Scientific instruments require it. And even spacecraft systems include ferrite-based filtering components to protect sensitive signals from interference. There's also a common misunderstanding about that small cylinder. Some people think it strengthens the cable, others believe it prevents overheating, and some assume it's simply decorative. But its real purpose is quieter than all of those explanations. It exists to manage invisible electrical noise that most people never realize is there at all, which makes it a perfect example of something ordinary hiding a surprisingly deep story. Because modern technology doesn't just depend on powerful processors and bright screens, it also depends on small, thoughtful engineering decisions like this one. Decisions designed to keep thousands of electronic signals working together without conflict. So the next time you notice that small bump on a charger cable, you're not just looking at a piece of plastic. You're looking at a solution to a problem most people never even realize exists. A small reminder that some of the most important technology around us isn't designed to be noticed. It's designed simply to work. And once you understand what it does, you'll start seeing it everywhere. Here on Ordinary Things Deep History, we explore the hidden stories behind everyday objects that quietly shape the modern world around us. If there's something ordinary you've always wondered about, tell us in the comments. Your question might become the next story we uncover together.